All right, so forget me trying to erase the left side of this. Instead, let me do this. I'll just do the graph again. What if I just draw the right side of the parabola? So in other words, I define my function, but then I tell you, look, only plug in values of x that are bigger than 0. Then that would draw just the right side. And that would pass both the vertical and horizontal line test, wouldn't it? So there's ways around it. We're not going to get into it. But I mean, I just want you to know, I don't want you to walk away from this thinking, oh, no parabola can ever have an inverse. It can if you cut it and make it so that you only get part of the graph. We're not going to do that in here. All right, if you take pre-cal, though, you do. And no one in here is supposed to be taking pre-cal. So, ready? We're going to move on. All right, so here's where we are. We know that inverses, we can determine if a function has an inverse graphically by just doing this horizontal line test. We know that for an inverse, you can flip all the points over and get the inverse function, right? And that it should be a reflection over the identity. And not every function has an inverse. How to find an inverse. So let me give you an example here. Take a look at that function. I want us to find its inverse. Can somebody tell me if this even has an inverse? And why? If it does, tell me why. If it doesn't, tell me why not. Why? What did I just show you? How to find or how to determine if something has an inverse graphically? What do you have to use? Horizontal line test. Well, that would mean you need to know what this looks like. What does 5x plus 4 look like? It's a linear function, which means it's a line, right? It has a slope of 5. It does something like this, doesn't it? Does that pass the vertical and horizontal line test? Yes, which means it has an inverse. All right, so we can tell it has an inverse just by the fact it's a line. But the question is how to find it. Now, when it was 3x, it was easy, right? Because you just take, divide by 3 and you undo it, right? But this one's a little more challenging because we have to undo 5x plus 4. So you ready to try and undo it? Okay, here we go. Here are the set of steps. You like steps? Here are the set of steps. First step, replace f of x with y. So I'm just going to rewrite the problem. Y equals 5x plus 4. Now step 2. Swap x's and y's. Now, what I'm doing here is kind of weird. Everywhere I see a y, I'm going to replace it with an x. Everywhere I see an x, I'm going to replace it with a y. Why do you think I would do that? Yeah, because remember in the graph we said our inverse, every x becomes the y and every y becomes the x? So that's what I'm doing. I'm going to force my y to now become an x. And then I'm going to force my x here to become a y. So my equation, nothing else changes. It's just the y becomes x, the x becomes y. The third step is to solve for y. So how would you solve for y here? Subtract 4 and then divide both sides by 5. You agree with that? I took the blue equation, I moved the 4 to the left side, and then I divided everything by 5. And I'll go one more step. I'm going to move it over here. I'm going to do 1/5 x minus 4/5. Actually, I'm going to put y in front of it. Y equals that. All I did was split the fraction on the left into 2 fractions, right? X over 5 and negative 4 over 5. And I wrote the x over 5 as 1/5 x. Now step 4. Replace y with, what do you think? What did we switch earlier? Remember the very first step? We replaced the functions f of x with y, right? I've done all the switching. I've got my solve for y. Now I want to switch that y back, right? But not to f of x, f inverse of x. So I get f inverse of x equals 1/5 x minus 4/5. There it is. That function should undo what f does. So it's a 4-step procedure. Okay? What the hell? Yeah, that's it. That is it. Now, I'm going to write down on a new page the two functions next to each other. We had f of x was, what was it? 4x? No. 5x plus 4. And we just figured out, we think that the inverse function is 1/5 x minus 4/5. That's what we came up with, right? How is it that I know that that's the inverse, though? I mean, how could I tell? Well, we could try something, right? We could try a number. We could graph it. Does it look like a reflection over the identity? Right? We could try things. How about we just pick a number and plug it in? Let's see what we get. I'm going to plug in 5, okay? Just plug 5 into the original function. So this is what it would look like. Plug 5 in, send it through f. What happens when I send 5 through f? What do I get? 29? 29. Everyone understand that? Now, when I send 29 through the inverse, what better come out? 5 better come out, right? Plug 29 into the inverse now. That means 1/5 times 29 minus 4/5. Do y'all see what I'm saying? But 1/5 times 29, that's the same as 29 over 5, isn't it? Minus 4 over 5. They have the same denominator. So you get 25 over 5, which is 5. So it works. Now that is no way to check if a function is an inverse, because just because it worked the first time doesn't mean it's going to work every time, right? But it at least makes us feel better that we got the right answer, right? Because if we got the wrong answer, that shouldn't work at all, period. Agreed? Yes. Okay, so that problem's done. I said find the inverse, right? And we found it. Now I'm going to start a new problem. But are there any questions? Okay, here's a new problem. How to verify two functions are inverses. Students historically do not like this, all right? Just FYI. So if I give you functions and I say, hey, are these inverses? You have to check them. And here's the official stamped approved way of showing that two functions are inverses. Here's what you must show. You must, given two functions, and I'll call them f and g, to show they are inverses, you must show these two things. One, f of g of x equals x. 2, g of f of x equals x. What the hell is that? It's fog and Goff, right? But why is it that I'm coming back to this now? What we need for two functions to be inverses, the first line is saying this. The first one, number one, is saying that if I send x through the first function f, then through the other one g, it comes out unchanged. So x goes in, goes through both, comes out x. Number two says what? You send it the opposite direction. If I send x through the other direction, it comes out unchanged. If that happens both directions, those functions are inverses. Okay? With me? Example. I'm not sure. Y'all should be happy. Y'all did good on that test. Why is everyone so down today? That's what Monday is for, to be tired on Monday. Verify f of x equals 5x. What did we have? Plus 4? Was it minus? Plus 4. And I'm going to call it g of x equals 1/5 x minus 4. Was it 4/5? What we just found a second ago are inverses. Now I'm calling it g instead of f inverse. So we already had shown earlier, we had determined that that's what the inverse was, right? That yellow one. But now I want to prove that they are inverses. I want to verify it. So I've got to do fog and Goff. Here we go. First one. Fog. F of g of x. Now you have to go back and remember what that meant. Fog was composition, right? You've got to go f, and inside f you're going to plug in g, right? But what is g? 1/5 x minus 4/5. Any questions on that? I'm just replacing g with what g is defined to be. Right? Now that goes into f. What does f do to something that you give it? 5 times whatever you give it plus 4, right? That's what f does. But what are you giving it? 1/5 x minus 4/5. Y'all see that? Distribute your 5 through the set of parentheses, and what happens when 5 goes through? 5 times 1/5 x becomes What's 1/5 of 5? 1. It's 5 divided by 5. So it's 1. So 1x. So just x. What about the next one? You're multiplying 5 times -4 over 5. 5's cancel. You get -4. Then plus 4. All right, plus 4 is out here. What does that equal? X. Isn't that what it had to equal? We said that fog had to turn out to be x. So far, we are happy. That's only half of what we have to show. Now we have to show the other way works the same. So now Goff. So now G is on the outside, F goes inside. That means G is going to get 5x plus 4 plugged into it. And what does G do to something that you give it? It's 1/5, right? Times whatever you give it. Then what? Minus 4/5. Yeah, I'll put that in there. Minus. That's what G does, right? 1/5 times whatever you give it minus 4/5. But we are going to give it 5x plus 4. Now distribute the 1/5 through. Tell me what you get. You get x plus, now 1/5 of 4 is 4/5, and then you still have the minus 4/5 out here, which equals x, and that checks. So now they are official inverse functions. Do I need to go back? Did I go? Yep, sorry about that. Are there any questions on fog and Goff here? And how you determine? All right, let's do. You don't have to graph them. Not yet. Yep. All right, find the inverse of f of x equals x over x minus 1. Does anybody recognize this type of function? That's a drum roll. Rational. Very good. That's a rational function. I could have asked you to sketch that on the last test, number 4. It's a polynomial divided by a polynomial. So you went through that whole procedure, right? If you went through and graphed this, you would find that it passes both the vertical and horizontal line test. This one would. So it does have an inverse. So the question is, can we find it? So what we're going to do now is go through that 4-step process to find the inverse. What was the first step of the 4-step process? Replace f of x with y. Replace f of x with y. That's what I just did, right? What's the second step? Okay, so what would it become if I swap the x's and y's? X equals y over y minus 1. Okay? We good there? Third step is what? Solve for y. So how are you going to get y by itself on that equation right there, number 2? You're going to have to get rid of that denominator on the bottom. So you're going to multiply both sides of the equation by y minus 1. Are you all paying attention? Because this is going to be part of your homework. Something like this. You're going to multiply the left and right sides by y minus 1. That will create cancellation on the right side. Right? Those y minus 1s cancel completely. On the left side, you just have y minus 1 times x equals y, right? Have we solved for y? Yes and no, right? I mean, yes, I do have y equals something, but what's on the other side of the equation? A y. So how are you supposed to know y if you have to know y to get y? Does that make sense? Like, if I asked you what y was on the right side, you would have to know what y is on the left side. So to solve for y means you have to get y by itself on one side. The other side can't have y's on it. So how in the world am I going to get the y's all on one side? Distribute the x through. You all paying attention? It's going to be on your homework. Distribute the x through. And now you get xy minus x equals y. Now what? If you divide by y right now, though, watch, you'll get y here, you'll get a y there, and you'll get a y here. So now what you'll have is you'll have a y in the middle term, and it'll be on the denominator. So that may work, but I think it is not the path of least resistance. In other words, there's probably a more efficient way for us to get there. What are we trying to solve for? So why don't we get all the y terms on one side, everything that doesn't have a y on the other side? So when I say that, I mean y terms are things that have y's in them. Let's get these two guys together on one side and get the other guy away from them. You can add the x to move it to the right and subtract the y on the right to get it on the left. So it would become this. xy minus y equals x. That okay? Now, why would I get all my y terms on the left side? Now you, not GCF. Now you can, since both terms on the right have a y in them, you can factor out a y. You could do negative. Doesn't matter. And now, how do I get y by itself? How are you going to move x minus 1 over? Divide it. Divide it on both sides. So if I take this and I come in here now and I divide both sides by x minus 1, you get y equals x over x minus 1. So we've solved for y, haven't we? Okay, number 4. Step 4 is to replace y with f of x, or f inverse. So the inverse function is what? X over x minus 1. What the hell? You should be scratching your head a little bit, right? Because isn't that the original function? Isn't it? So the inverse is itself. That just doesn't seem right, does it? So maybe we should verify that they are inverses. Because maybe we're not real sure. So how do you verify that these two are inverses? Fogg and Goff. Right? New page. This is what your homework's going to be. I'm going to give you a function. I'm going to tell you to find its inverse. Then I'm going to tell you to verify their inverses. And that's what you'll see on the test. So here we go. Verify that f of x equals x over x plus, was it minus 1? Yeah. And g of x equals the exact same thing are inverses. Because maybe we messed up a sign or something in there. Maybe there was a little mistake we made. All right, so let me try the first thing, which would be fog. F of g of x. That means I take f, inside of it, I plug in g. Which means I take f, and inside of it, I'm plugging in x over x minus 1. Now be careful here. Everywhere I see an x in the f function, I'm replacing it with what? X over x minus 1, right? I'll write down f next to this. F of x looks like this. X over x minus 1. So I'm going to replace the x and the x here with x over x minus 1. It's going to look ugly. It's going to be what we call complex fraction. Let's see what happens. We get x over x minus 1 on the top over x over x minus 1 minus 1. Does that look bad? Well, no, because we have the minus 1 down there. They would cancel if there wasn't a minus 1. All right, you ready? Follow me on this. What do we need this to become? X. All right. So what I'm going to do is I'm going to notice that I have a denominator here of x minus 1 and a denominator here of x minus 1, right? They're both the same. So something in the numerator and denominator both have x minus 1 in them. I'm going to multiply the top of this problem by x minus 1, and I'm going to multiply the bottom of the problem by x minus 1. Because x minus 1 over x minus 1 is really a 1, isn't it? Now watch what happens. This x minus 1 on top cancels with that one, doesn't it? Now the x minus 1 on the bottom must distribute because there's two terms. See the two terms on the left? That x minus 1 must go to both. So take the entire thing, x minus 1, and multiply times that first one. What would happen if we multiply that times this? The blue times the blue on the right. Those x minus 1s would cancel, wouldn't they? And what would it be left with? Just an x, right? So when I go from here to here, the x minus 1s cancel and I get an x. What would happen when I go here to here? It would just turn into one times it is itself, right? But then the negative would change its signs. So let me put this all together in the next line. This equals, the top was x, right? The bottom was x, and then we said it would change the signs. It would become minus x and then plus 1. The minus x right here comes from multiplying that x times negative 1. Those two together give us this. Do y'all see that? And then the positive 1 comes from taking this negative 1 and multiplying it times that negative 1 there. That kind of makes sense? And holy crap, what happens there? On the bottom, what's x minus x? 0, and then we have plus 1. So the bottom is just 1, isn't it? What's the top? X. And that's what we wanted. Now, Goff. Do we really need to even do Goff? It's the exact same algebra, isn't it? It's the exact same problem. So we know it's going to come out x. So it's verified. It's kind of interesting, no? Was it x minus 1 on the bottom? All right, there's the function, okay? There it is. You'll see it? It's the one in the dark blue. That's our rational function. If I draw the identity, diagonal. I use a marker that works. What do you notice? It's its own reflection. It is its own reflection. If I take this piece on the right and I reflect it over, it lands right on top of itself. And same thing on the bottom. Reflect it over, it lands on top of itself. So this is a function that is its own inverse. That just happened just by complete chance. I wasn't intentionally trying to make that happen. So somewhat of an interesting problem. All right. I think everyone's ready, aren't you? I can tell you're ready. So what I'm going to do is this. I'm going to cut you loose after I somehow, well, everyone's pretty much here, huh? Let me hand back these last tests, and then I can tell who's not here. Natasha, no, Natasha, Jesus, Denise, Veronica, okay. I know everyone wants to jump out of their seat and get out of here, but hear me out for just a second. Yesterday was the deadline for posting midterm grades. So I did that. I have to do it officially through the school. And there's an automatic system that if you are not passing, all right, that it will send you an email from me. It's going to come from me, but I didn't really send it. It's automatic. And it says, like, please contact me about your progress in this course. And then after that, I sent another email, which I intentionally sent, that said, hey, if you haven't taken your exam 2, don't worry about it. Wait till after exam 2 to contact me. Well, this class, you already took your exam 2. So if you are not passing this class, I recommend you come talk with me about options and where you are and what's going on, okay? Because if after the second exam you're still struggling, it's going to be a challenge for you to get through this course, and I want us to at least have that dialogue, all right? If you are not passing multiple classes, the system will automatically do something. I'm not sure how it does it, but it'll like force you to go see an advisor. So if at midterm you're not passing multiple classes, just be prepared to have to go see an advisor or something like that. It's just FYI for you, all right? I am going to email you a homework assignment within the next 2 hours because I'm about to go give an exam, and while I'm giving the exam, I'm going to come up with your homework assignment. I'm going to send it out to you, okay? All right, everyone. Have a great day. I would have given you the day off today, but the Cowboys won, so we're all going to suffer.